On previous lectures we were talking about software, how to write simple software for ESP8266, how to access ESP8266 with the web browser and simple MQTT library. And now I will tell a few words about ready tools and frameworks that you can use also using ESP8266, but also other interesting devices. But we start with platforms that allow us to create the home automation systems. So we will talk about home automation platforms, and next about software created for ESP8266, but also some other boards. Ready for use software with the example based on Tasmota. This is very popular framework, very popular firmware for ESP8266 and ESP32 chips. So how to create your own home automation system, how to connect the elements that you want to control, that you want to read the data with your own home automation system based on IoT devices. Let us start with explanation what we have available on the market. We can say that we have many commercial systems that they compete, and we have hub devices that we can say they perform the role of the central device of your home automation system, and many companies create such hub devices. For example, Amazon Echo, Apple HomeKit, Google Nest Hub, Samsung SmartThings, and I found also something that is named Wing Hub. This is the device that enables us to connect different elements of IoT infrastructure to one central point, but we also have possibility to connect our home automation system to cloud. And we have cloud services that allows us to implement much more complex automation algorithms, also recognize the voice, for example. And we have cloud-based services like Amazon Web Services, Google Cloud IoT, Microsoft IoT version of Azure, Arduino IoT Cloud, IBM Watson IoT, and also Cisco has its own cloud solution for IoT. We have also some commercial systems, we can say ecosystems, that they are provided from a specific producer, specific provider. And Xiaomi has its own set of devices that we can connect together, creating one IoT home automation ecosystem. And there is also such a company named Tuya. They produce the devices for their own brand, but also for some other brands. Many different brands buy elements, buy devices from Tuya, and normally you can find that such device is marked as Tuya based or Tuya compatible. It is possible to connect such devices together to create your own full compatible IoT ecosystem, but Tuya always works with the Tuya Cloud. If you have different providers for your IoT devices and for the elements of your system, normally you need some integration to be able to, I don't know, for example, control your heating with the temperature, and the heating comes from different providers than your temperature measurement device. You need to make some integration. And we have some integration services. One example is ITTT. So if this, then that, you can here create your own rules how to make the automation, how to make the connection between different elements of your home automation IoT system. And of course we have also open source software, and if you are a computer engineer, if you are studying something connected with computer science, computer engineering, this is a solution for you, because this is highly configurable And of course, this is open source. You have influence on anything. You can create by your own rules and functions, and you can connect devices coming from different vendors. Examples of such systems are Domotics, quite popular, OpenHub also popular, but the most popular I think is Home Assistant that has huge supporting community, a lot of different libraries, and it also enables us to create our own version of ESP8266 software that I tell in the moment. But if you are even more advanced in computer programming, but I would say not highly advanced, a little bit more advanced, you can use Node-RED tool that you can create your own functions, you can create your own programming interfaces with your sensors, with your actuators. You can create your own dashboard, so web page that you can observe what's happening in your home automation system. Now a few words about the devices, because you know we have the central point, we have the cloud, we have some integration service, but we have also a lot of different devices that we can use as our IoT ecosystem. Some devices support directly chosen IoT protocol. It can be MQTT, it can be CoAP, it can be some other protocol, but this is not very common. Unfortunately, a lot of devices support only the proprietary protocol created by the vendor. So if you want to connect, if you want to use this device, you need to use the application interface provided by this vendor, for example, using the cloud. But sometimes it is possible to change the firmware on this device with some other firmware. I do not recommend this solution if you are not familiar with electronics, if you are not familiar with computers, but if you are, it is quite interesting and we can say somehow challenging. We have few different firmware versions or firmware examples that you can upload to ESP8266 and ESP32 devices. Such device sometimes you can obtain from the market, because some of these devices sold in shops are based on these two chips. Sometimes not, so you need to be careful. Or if you create your own device, you can also use the ready firmware that makes creating of your IoT device much more easier. Examples of such ready firmware are Tasmota. ESP32 version is also available now. ESPurna, this is not very popular. ESP Home, this is the version that is created automatically by Home Assistant. This is very nice and interesting feature. And there is also something called a ESP Easy. I will here present you the firmware named Tasmota. I'm quite familiar with it and I really like it. I think it's very useful and very configurable. So first let's start why Tasmota. Very good documentation. It has big community with the very good documentation available on their web page and also available on GitHub. It has already binaries, so you don't need to compile your own binaries. You can choose some version of general binary. Of course, you can also create your own binary on your own computer, but also using WebTool. Configuration of the Tasmota is made via web interface, so while you upload the firmware to the ESP8266, you connect to it using your Wi-Fi network, and you can configure it fully. What is this device, what inputs, what outputs, what protocols it supports, configure MQTT, your network credentials, everything. We have templates for configuration for different devices, so if you buy some device that is possible to make it working with Tasmota, Normally you have the template that you just upload to this device, and it's very easy to use it. If you Tasmotize your device once, you can upload new version using over-the-air protocol, so you don't need to connect any computer to it. Using Wi-Fi you can upload new version of Tasmota. Support for many devices. All the list of supported devices is available in the documentation, so this is also very comfortable. It supports MQTT protocol, so you can make your home all devices, all the list of the devices compatible, and of course available for free using GPL version of license. Most important binaries that you can find is, we can say, general binary tasmota.bin. It includes most common features. Of course, everything you can configure here. We have version is especially created for different sensors. We have minimal version just for uploading new version of over-the-air firmware. We have light version with reduced binary. It is intended for constrained devices. I shown you during our lecture on hardware that we have different versions for ESP8266, for example, such version that has limited memory, and especially there is a version named A285. It has built-in flash into one chip, and it has half megabyte of memory, so it is not very big, so this light version is suitable for this. And we have also display with support of for different displays, and also some others that I do not mention here. We have web tool that is named Tasmo Compiler. You can create your own binary version with some parameters that you can set up with this on this page, and create your own binary, and after this load this binary to your ESP8266 device. The easiest way to upload the first version of Tasmota into your device, but not only Tasmota, any binary that you need to upload to your ESP8266, you can use the tool that is named Tasmotizer. Tasmotizer operates with local USB port, so like Arduino framework. Yes, you can connect your computer using USB port to ESP-D1 device and Tasmotize, so upload the Tasmota firmware to this device. You can also upgrade Tasmota using web tool, using over-the-air. If you already have Tasmota on your device, you can choose the new binary and upload it automatically through Wi-Fi. An example of Tasmota, we will use the same D1 mini board based on ESP8266 chip as we shown on during our previous lecture. We know it already. It has 3 LEDs. It has 1 button. So I won't repeat it now. So let's Tasmotize it. After Tasmotizing it, as I said, it's quite simple, just USB cable to your computer, Tasmotizer software, and uploads the newest version, for example, general binary. We can connect to the network exposed by the Tasmota after power on. It is usually named Tasmota with some number automatically generated by our chip. It is based on the serial number of our chip. So it creates the access point that we connect to, and using the web address 128.168.22.68.41 we we connect to it and make the configuration. For the beginning we need to configure the Wi-Fi network with some SSID of our network and the password. This is information about the SSID and the password for our network here at the university. And after reloading, after rebooting, our Tasmota tries to connect to our Wi-Fi. And new versions of Tasmota, if you don't close the browser, a new version of Tasmota will present you the IP address that it uses for the connection to your network, to your Wi-Fi network. So it is quite easy after this to obtain the IP address. If not, you always can refer to the list address of your DHCP server in your access point or router. So you can use this information where to connect to make further configuration, because at this time we have only the network credentials configured in our Tasmota device. After this we need to configure it further. So for example, configure the hardware and configure MQTT. This is how the basic Tasmota view looks like after first connecting. We don't have many possibilities here, but we have available configuration. So after clicking configuration, we have possibility to configure module, Wi-Fi credentials, MQTT configuration, compatibility with domotics, and also configure template or configure other. If our board is compatible, if our device is compatible with some other device and we have the template for it, we can use the template. If not, we can use other and configure which GPIO pin is responsible to control or to read the data from which sensor or actuator. So for example, we here configure the template with we specify the name of our template, and we configure connections like in the previous lecture. So GPIO 5 is button, GPIO 12 and 14 are two LEDs connected as PWM, because ESP8266 and Tasmota supports changing the intensity of light using PWM protocol, or PWM technique rather. If we configure the template, here we can provide the template. We can download this template from the website that describes different devices. And if we use this template, we need to activate it, and also it is good to activate MQTT to be able to communicate using MQTT protocol with topics. So you can also specify the unique name, and this unique name will be used as the part of your topic. And after this, after such simple configuration, so we need to provide information what is connected to which pin. We have some controls here on this website available. Notice that we have toggle button and we have two sliders, and these sliders allows us to change the intensity of the light. This is the lower slider, and the upper changes the, we can say, color temperature, because if Tasmota sees that we have two LEDs, it thinks that we have bulb that we can change the color, the temperature color between cold and warm. So we have such two sliders here. And the sliders changes intensity of our two LEDs, but not separately, and a button that switches on and off our, we can say, bulb. We can configure, of course, mini our D1 Mini for MQTT protocol. So we need to provide the IP of our host. Here, this host is, of course, the address of MQTT broker, the port of MQTT broker, and the client is generated automatically and normally differs every ESP8266 chip, because this number is created based on the serial number of the chip. And here we have user name and the password, and if we have the MQTT broker with credentials, we need to provide here the username and the password. And here we also provide the topic and the full topic. Topic is something that differs between different Tasmata devices. So here we can specify what is the kind of this device, and full topic also allows us to make something like a grouping of our devices, and also allows us to modify the default topic for Tasmata, because default topic for Tasmata is prefix plus topic, so what is defined here, plus command. Command is defined by Tasmata software. Prefix also is defined by Tasmata software. I'll show you a few examples. Prefixes. CMND, it means command. This is the prefix that is used while we publish the message to control our device. So for example, if we want to switch our LED on or off, we will send command. Next we have stat. Stat is the report, so we can say something like status. It is report or configuration message used to know the state of the Tasmata device. So this is, we can say, report from Tasmata message. And we have also tele. Tele is the current result of measurements. So this is different than status, because status is sent for every device, even bulb, because bulb, for example, gives returns with the information, okay, I am on, okay, I am off. But tele is the something that is sent by sensor devices. So for example, temperature measurements. Some commands, so some suffixes that we add to our topic are, for example, power with the value on and off, or 0, 1. We have dimmer that allows us to change the intensity of light. Color that allows us to change the color. If we have RGB LED, we have here 3 hexadecimal elements, and we can specify the color in the same schema as on web pages. We have also channel 1, channel 2, so here we can change the intensity of the specific channel, so the specific LED, like in our example we use 2 LEDs, so we have channel 1 and channel 2. We have also console in our Tasmata environment, and it allows us to control details of our system, but also allows us to observe what are the topics, for example, of the tele messages or of the stat messages that are sent by Tasmata. So because normally we don't know them, we need to read the documentation, but here we can observe, for example, that MQTT protocol send the message stat Tasmata with the number and power off. Yeah, so this is the information that our device has switched off. And notice that here we have also prefix, this is stat, command, this is here, this is power or and the payload, or on or off, and here we have the power and we have result. Yeah, so this is how we can get the information about the topics that we need to use in our MQTT topic system. It is also possible here to test commands, because this is console, not just gives us the information, but we can also write something and send the message to Tasmata device and influence its behavior. Here we can also create some rules. For example, if we want every time when we switch the power of our device on, it will make our color of our bulb, for example, red. Yeah, everything is possible to make here. Another example I want to show you is the sensor device based on Tasmata. This is a sensor device that uses the LDR, so light dependent resistor. Also based on the same D1 mini board. We need to first Tasmatize it. After this we have to configure it. We know that this LDR is connected to analog input of our board, ADC0, so we have here ADC0 and light sensor. Of course, it won't give us the information in luxes, because it must be recalculated somehow. But we will have the information about the intensity of the light. Of course, we need to activate the template, activate MQTT, and this is the information how the picture it looks like. It says it is in luxes, but I'm sure this is not the proper value, because the luxes depends on the characteristic of the specific LDR, and they are different. So this is some reading somehow recalculated. I think this is the result here is recalculated by the formula, we can say, in some general LDR. So it reads the level of illumination, and MQTT messages are sent every 300 seconds by the default, but you can modify it. Of course, it's not good to send very big amount of messages in a short time, so make always the frequency of this reading compatible with the need of your sensor. And there is a command named teleperiod, and this teleperiod command specifies what is the the delay between concurrent measurements. And what is I would say small drawback, but maybe slightly small drawback of Tasmota, because it doesn't send these readings as the simple payload, but it sends this as the JSON encoded message. So if we want to read this data with some other device, we need to also make something like decoding JSON or parsing JSON, or we need to have the software that converts these messages from JSON, for example, to Tasmota commands. If we want to, for example, control a bulb or control the light with light intensity measured with some other Tasmota device. So as you can see here, we have the measurements tele with the Tasmota sensor. So to such topic we have, and we have the information. What is the time here, and what is the payload? So time and analog, illuminance, and the current value. Analog means we have analog measurements, illuminance means that we have the light sensor, and the current value is the same as it was displayed on the Tasmota web page. So here 472, this is somehow in luxes. So we can say if we reformat it to JSON compatible string, it looks like this, or compatible record, it looks like this. So to parse this JSON record, we need to find the analog field and illuminance field, and here we have the value of this field. I told you about this application last time, about MQTT-application, and MQTT-application has implemented possibility to parse the JSON payload. So as you can see here, we have this light detector, we subscribe the topic tele, Tasmota, and sensor, and here we extract from JSON path the beginning of the path, we can say the root, analog, and illuminance fields. And if we write something like this in our MQTT-application, we will achieve, of course, we need to have the proper tail here. This tail here is we can say range. We need to specify the minimum, the maximum. Minimum is 0, maximum is maximum value that can be encoded in 16 bits. And with disable publishing, and we will obtain such, we can say, range information about the current reading from our sensor device. And now a few words about Node-RED that I mentioned at the beginning, that this is something like programming environment for our IoT and home automation systems. And here I'll show you how to connect this LED I created and this LDR node I created. Few words about Node-RED. This is created by IBM. It is based on some such paradigm like flow-based programming. So we create such schematics of the flows in the moment there will be such. This picture here shows the idea of this flow-based programming. It is available through web browser, so we edit these flows from web browser, and after this it somehow works under the hood. It can work on Linux, it can work on Windows, it can work on Raspberry Pi. It can cooperate closely with your MQTT broker, so this is a very nice tool for making rules for your automation. How to connect to Node-RED? Normally you can open the editor on the port number 1880. So if you install it on some computer, you can use the IP address of your computer, of your local computer, with port 1880. You can create the flow and deploy it and configure nodes. How to do it? Let me explain. Here, very simple, controlling the power of the MQTT device with two buttons implemented as buttons in Node-RED. So we have two injection nodes, one is on, second is off, and we have MQTT publish node, this one, that we can configure, use some topic, and we can, using these two buttons here, we can turn the LED on or off. How this injection nodes look like? We have here the injection node. Of course, we need to pick up the injection node because here you have the set of different possibilities, set of different nodes. You pick up inject node, put it here, make this connection, and this is everything. And here you create what is the payload that you send while the node is clicked. Yeah, so while on the screen on this web page you click the node, the on payload will be sent as text type, and of course the other node should send off. And MQTT publish node, you specify what is the IP address and the port of MQTT broker here, and what is the topic. The content of the topic will be generated by this injection node. So this injection node creates the object named message, and this message object is sent through this MQTT publish node to MQTT broker. So it looks like this. If we press this button here, the LED will be on. If we press this button, LED will be off because of the MQTT message sent. This green square here presents the status of the connecting to MQTT broker. If everything is properly configured and you have provided proper address, you will observe here such green square. That means okay, everything works, and our Node-RED was able to connect to MQTT broker. So let us connect two devices. As we said, we have the LDR, and we have also this lamp with these three LEDs. And what we need to remember here, that everything in the Node-RED is an object. This is object programming. So how to do it? We subscribe MQTT topic. We make some data processing here, and we publish another MQTT topic with some information that is result of our data processing. So we need the function in between, because as we said, Tasmota, our light sensor, generates the JSON message. Here we have something simpler. Yes, we have power on and off or something like this, or the dimmer, depends on what we want to do. So subscribe node. We specify the broker with the port. We specify the topic that we want to subscribe. Notice that this is the topic that we used in our LDR sensor. Yes, so tele, Tasmota, and sensor. And we know that Tasmota generates the JSON object. So here we use type of the output of our MQTT node, parsed JSON object. Publish node is quite similar to this publish node, publish tile that we configured in MQTT dash. We have we have this broker address, localhost, because I made this example on everything on the one computer. So on the same computer I had the MQTT broker and Node-RED, but here you specify the IP address of the broker and the port. Here you specify the command that you want to send. Notice CMND, Tasmota, and the dimmer. Dimmer means we will be able to change the intensity of the light. And the function that is in between these two nodes. This function looks like this. It's not very complex, but I will explain it. This function is for processing JSON messages. So this function looks like this. We have JSON payload is the payload of our message. So message payload is the input for our function. We know that we need to extract from this message field .analog.illuminance, because there is a content of our field. So the X value, the resulting value, will be value sent as illuminance field of the analog from the payload of our message. Okay, so such path to extract the value that we are interested in. And this extracts the number from the JSON object. What is important here? This description here is case sensitive, so it must be analog with capital letters here, it must be I capital here. Function decides what to do with our output basing on this value of this LDR. So if our returning value X, remember X is created here, if our value X is higher than 100, we will reduce it to 100, to be able to limit the value of the X, because we know that it can change from 0 up to 64 kilo. It doesn't make any sense. So it reduces the output value to 100, and we convert this X value, that is number value, to string, set it as the payload of the message that we want to send further, and return the message. Only 4 lines in this function are enough to convert the version encoded in JSON into something simpler, that is string of the value X. Notice that this X changes from 0 up to 100 because the dimmer works only with such values from 0 up to 100%. And this is all. It should work. If you make the LDR with the higher value of luxes, you will be observed that your light will be brighter. Of course, if it makes sense, I don't know. It's just the example how to handle such JSON encoded messages and how to control other Tasmota devices using conversion made in Node-RED. Okay, I think we are somehow ready to make our home smart. I hope you will have fun with it and you will experiment. You will make your own nice devices, and wish you luck with it. Thank you very much.